Hello, my name is Marius Bonchica, and I welcome you to my coursework 1B, testing through the software lifecycle. Software testing ensures the program not only satisfies predefined standards, but also operates dependably and safely in a range of scenarios. Producing software of the highest standards requires understanding of the testing phases and how they correspond to various development methods. The many software development models, important test levels, testing kinds, and the function of maintenance testing in guaranteeing long-term software reliability are all covered in this presentation. Software development models are in number of five, that being waterfall model, iterative and incremental model, V model, spiral model, and agile and scrum model. The waterfall model is a linear and sequential model is having each phase separate that must be completed before moving on, and the phases are requirements, design, development, testing, deployment, and maintenance. Is suitable for well-defined stable project, and is difficult to accommodate changes late in the process because you have to go through each phase again. The V model, is called verification and validation model, is an extension of waterfall model, and each development phase maps to a testing phase. It encourages early test planning, and verification is uh, meaning building the product right, while validation is meaning building the right product. Iterative and incremental model, it breaks the development into smaller cycles, basically iterations. Each iteration delivers a work in product increment, encourage early feedback and continuous improvement. The spiral model is an iterative development plus a systematic risk analysis. Each loop in the spiral represents a phase like planning, risk analysis, engineering, and evaluation. Is the best choice for large, complex, and high risk projects. The agile is delivering working software rather than extensive documentation, is adapting to change instead of strictly following a fixed plan. The sprints are usually lasting 1 to 4 weeks and include daily stand-up meetings to discuss progress and address obstacles. The structure agile framework that organizes software development to define methods and clearly assign roles is called Scrum, and the Scrum roles are Scrum Masters, Product Owner, and Development Team. The Scrum Master facilitates the process and ensures the Scrum framework is correctly followed. The product owner acts as the voice of the stakeholders and manage the product backlog. The development team is responsible for building and delivering the product incrementally. There are four main test levels: unit test, integration testing, system testing, and acceptance testing. The unit or the component testing is performed by developers, test individual units components of the software, detects logic errors, boundary conditions, and internal functions. Integration testing tests interaction between integrated units of the system, may be performed by developers or testers, and focused on interfaces and communication paths. The system testing tests the entire system as a whole, is performed by an independent qualified team, and ensures the system meets functional requirements and non-functional requirements. The acceptance testing validates the software against business needs, is performed by end user or customer, determines whether to accept the software for deployment. The software test types. There are functional test types, non-functional test types, structural test types, or regression and retesting test types. The functional test types are based on functional requirements or specification. Verifies software behavior, for example, login functionality, search functionality, checkout functionality. Includes system and acceptance testing. The non-functional testing is based on non-functional requirements, assess performance, scalability, security, usability, or reliability. Example of non-functional testing are the load testing, the stress testing, usability testing. Real-world testing can be done on the K6 IO. The structural testing are known as white box testing, involves testing the internal structure of the code. For example, the code paths, the loops, the code logic. Use metrics like statement coverage, decision coverage. The regression retesting verifies the bugs and functionality. Retesting verifies and specific fixes for bugs, while regression testing ensures changes didn't unintentionally break existing functionality. The types of regression testing are selective, progressive, corrective, partial, complete, or retest all. The maintenance testing is essential for long-term health after deployment. So it's performed after changes such as bug fixes, enhancement, or upgrades. Includes retesting modified parts and regression testing for affected areas. Is vital for agile and DevOps environments with continuous deployment. Ensures software remains reliable and functional as it evolves. In conclusion, is is essential to understand testing at every stage of the software lifecycle. Delivering dependable, high quality software depends heavily on testing at every stage of the software lifecycle. Teams can execute successful and efficient testing methods when they have a solid understanding of the development models, the various testing levels, and the different types of tests. By proactively addressing upgrades and modifications, maintenance testing guarantees that systems continue to be stable and operational after deployment. When taken as a whole, these procedures promote customer happiness and ongoing software development. So I prepare five practice questions, and I prepare as well five reflective questions in regards to this presentation. The practice questions are number of five, as I said, and the first one is which of the following is not a software development model? A waterfall, B agile, C spiral, D binary. The correct answer will be D binary, and because binary is a data representation format, not a development model. Why waterfall, agile, and spiral are uh, development models? Who typically performs unit testing? A. Customer, B. Developer, C. Independent qualified team, D. Business analyst. The answer is developer because unit testing is done by developer to verify individual code components. Uh, Question 3. Which testing level validates if a complex system meets the specified requirements? A. Unit testing, B. Integration testing, C. System testing, D. Regression testing. The answer is C. System testing because system testing validates the full integrated system against requirements. Question 5. Functional testing is primarily concerned with A. How fast the software runs, B. User interface design, C. Checking if the software does what it should, D. Software maintainability. Correct answer is C. Checking if the software does what it should because functional testing ensures the system behaves according to specifications. Question 5. What is the main focus of regression testing? A. Finding new bugs. B. Testing performance. C. Ensuring changes haven't broken existing features. D. Verifying system acceptance. Correct answer is C. Ensuring changes haven't broken existing features because regression testing ensures that updates do not negatively impact existing features. So now we are wondering why is such important the testing? So we have these five new reflective questions as being the first one. Why is it important to understand different software development models? Since each project is unique, we can select or suggest the optimal strategy for the project requirements by being knowledgeable about models like waterfall, agile, spiral, which will increase productivity, quality, and customer satisfaction. And as well, we are not gonna do unnecessary testing if is a project too small or too big, or you gotta perform the right model if a project is indeed uh, done to be scalable. Second, why do we need to distinguish between the four test levels? Since every test levels like unit test levels, integration, system or acceptance testing has a distinct function, we may apply the appropriate test at the appropriate times and prevent expensive errors later in the development process by being aware of their differences. 3. Why should we care about the type of testing like functional, not functional, structural, or regression. Due to the simple fact that software quality is complex, if we solely concentrate on functionality, we may overlook important problems like stability, security, or performance. If we understand the many types of tests, we can take a broad approach of testing. 4. Why is maintenance testing relevant even after the product is released? Since software is never fully completed, improvements, problem fixes, and updates it might happen in future. So maintenance testing guarantees the product continue dependably and user confidence. 5. Why is essential to align testing activities with the chosen software development model? Since the software lifecycle is structured differently by each development model, aligning testing guarantees that quality assurance is incorporated at the appropriate points. For instance, while testing is frequently sequential in waterfall, it it must be continuous and flexible in agile. Ineffective procedures, overlooked flows, and elevated project risk can result from misalignment. That was from me. I wish you a good day. Marius Bonchica.